All right, so let's take care of a couple of examples here where we're simplifying complex rational expressions. All it means by complex rational expression is that there's a fraction within a fraction, right? So we're going to do this systematically here. We're going to simplify the numerator first, and then we'll go back and do the denominator there. Remember that when we divide, it's like flip and multiply, right? So the first thing, though, let's see if we can simplify the numerator. This is similar to a previous example there where in the numerator, I'm going to just do the numerator right here. I've got 6y minus 4x. The LCD there is going to be yx. So the first fraction is missing that x over x, right? The second fraction is missing the y over y. So this is going to become 6x over xy minus 4y over xy. Now that we have a common denominator, we can simplify to 6x minus 4y, all divided by xy. So that new numerator, this is actually going to become 6x minus 4y divided by xy, all divided by y. So we simplified the numerator. The denominator doesn't need to be simplified any further. Now we're going to actually kind of rewrite this as multiplication, right? So we flip and multiply. Remember that this y in the denominator, I can technically write this as y over 1, right? So when I flip and multiply, it's going to be 6x minus 4y divided by xy times flip and multiply 1 over y. Okay? And so then I can simplify this. I just multiply straight across. Well, 6x minus 4y times 1 over xy times y. So this is going to give me 6x minus 4y divided by xy squared. So again, we just simplify the numerator, simplify the denominator, flip, and multiply. All right, so let's take a look at another example. This one looks a little more complicated, but it's okay. Same idea, right? So I'm going to start with my first fraction, my numerator. So it's 2c over c plus 2 plus c minus 1 over c plus 1. Again, nothing is shared, right? So I'm going to have an LCD as the product of c plus 2 and c plus 1. So the first fraction is missing that c plus 1. The second fraction is missing that c plus 2. So my new fraction, my new numerator is going to be 2c times c plus 1 over c plus 1, c plus 2, plus c minus 1 times c plus 2 over c plus 1 times c plus 2. And then I can add them. I would probably kind of honestly just simplify the numerator in terms of factors. So I'm going to leave this as 2c times c plus 1 plus c minus 1 times c plus 2, all divided by c plus 1 times c plus 2. And the reason I did that is if you look at the denominator there, I think we might be able to kind of do something with that, right? So that's my new numerator. And then remember, we flip and multiply. So this is going to be equal to 2c, c plus 1, plus c minus 1, c plus 2, all over c plus 1, c plus 2. So that's my numerator, times, flip the denominator, c plus 1 over 2c plus 1. Okay, so remember when we multiply straight across. But let's see if we can simplify anything, see if that's going to help us at all. Let's see. This is going to be what? 2c squared plus 2c plus c squared. If I'm simplifying this numerator, c squared minus 2c c squared plus 2c minus c minus 2. I still have this over c plus 1 and c plus 2. So notice I'm not simplifying that denominator there because I see this c plus 1 that I think I'm going to be able to cancel out, right? Let's see what the new numerator will be. So I've got 2c squared. I've got another c squared. So I think that's going to give me 3c squared. I've got 2c plus 2c. So that's going to be 4c minus c. So plus 3c. And then I've got minus 2 all over c plus 1, c plus 2 times c plus 1 over 2c plus 1. All right, let's see what we can do now. So remember, we multiply straight across, cancel common factors. So this is going to be 3c squared plus 3c minus 2, c plus 1, divided by c plus 1, c plus 2 times 2c plus 1. So I think we can cancel our c plus 1s, right? And so our final answer here is just going to be 3c squared plus 3c minus 2, all divided by c plus 2 and 2c plus 1. And at this point, if you're kind of wondering, would the numerator simplify, we could check that, but if we kind of go back and look at our factors, right? Looking up here at this step, in our numerator, we had a 2c and a c plus 1, and we had a c minus 1 and a c plus 2. So even if we were to multiply and simplify, I don't think any of that's going to factor to simplify. So again, when we solve these complex rational expressions, simplify the numerator first, simplify the denominator, flip the denominator, and then multiply like normal.